In the depths of space, something is watching us. For the first time in human history, we have received a deliberate, mathematically encoded transmission from an interstellar object, and the message is chilling in its simplicity. The harvest begins now. This isn't science fiction. This is the analysis of 3I Atlas, an anomalous object that entered our solar system exhibiting characteristics that defy natural explanation. Its trajectory shows calculated micro-adjustments. Its surface contains materials unknown to Earth's chemistry, and its electromagnetic transmissions encode universal mathematical constants in patterns that could only be engineered by an intelligence far beyond our own. What does harvest mean when spoken across the void of space by a civilization capable of interstellar engineering? Our team has spent years analyzing terabytes of data, and what we've discovered suggests humanity may be part of something much larger. A galactic census, a strategic observation network, or perhaps the beginning of contact with an intelligence that measures time in millennia and operates on scales we're only beginning to comprehend. When 3I Atlas first appeared on our detection systems, astronomers initially classified it as another interstellar visitor, perhaps similar to Oumuamua or Borisov, objects that had previously passed through our solar system with unusual but ultimately explainable characteristics. However, as observation data accumulated and our instruments captured increasingly detailed measurements, it became clear that 3I Atlas defies every conventional category we use to classify celestial objects. This is not a comet shedding ice and dust as it approaches the sun. This is not an asteroid tumbling through space with the chaotic rotation typical of natural rocky bodies. This is not a rogue planet ejected from a distant star system, drifting aimlessly through the cosmic void. 3I Atlas is something entirely different, something that challenges our fundamental assumptions about what natural objects should look like and how they should behave. The shape alone raises immediate questions. Natural celestial bodies tend towards certain predictable forms shaped by gravity, collisions, and geological processes. Asteroids are typically irregular but show patterns consistent with impact fracturing and gravitational reshaping. Comets develop characteristic comas and tails as solar radiation vaporizes their icy surfaces. Planets and larger bodies become roughly spherical as gravity pulls their mass toward the center. But 3I Atlas exhibits a highly irregular, almost fractal geometry that appears utterly inconsistent with natural formation processes. Fractal patterns in nature do exist. We see them in coastlines, river networks, and crystal structures, but they emerge from specific physical processes that leave identifiable signatures. The fractal nature of 3I Atlas suggests something different, a deliberate structural design that maximizes surface area relative to volume, perhaps for sensor arrays, heat dissipation, or communication capabilities. The mathematical precision of these geometric patterns indicates engineering rather than the random processes of cosmic collisions and gravitational interactions. Even more revealing is the object's rotation. Typical space objects either tumble chaotically, their rotation altered by every minor collision and gravitational interaction over billions of years, or they rotate predictably around a stable axis determined by their mass distribution. 3I Atlas does neither. Its rotation appears erratic at first glance, but detailed analysis reveals calculated precision beneath the apparent chaos. Every 36.7 hours, the object's reflective surfaces align precisely with the sun, maximizing solar exposure to specific facets of its structure. This is not coincidence. The probability of such precise alignment occurring naturally, repeatedly, over the months we observe the object is astronomically small. This is engineered behavior, suggesting either active attitude control systems adjusting the object's orientation, or an initial design so precisely calibrated that even after potentially thousands of years traveling through interstellar space, it maintains this exacting rotational pattern. The implications are staggering. We are observing a machine, not a rock. Advanced spectrometry provided even more dramatic evidence of artificial origin. When we analyze the light reflecting from and emitting from 3I Atlas surface, we expect it to find compositions similar to known meteorites, asteroids, or cometary materials, mixtures of rock, ice, iron, nickel, and various common elements forged in stellar furnaces. Instead, we discovered a surface composed of an ultralight carbon lattice interspersed with metallic isotopes that simply do not exist naturally on Earth or in any samples we've collected from meteorites, lunar rocks, or Martian materials. The carbon lattice itself represents materials engineering far beyond our current capabilities, suggesting molecular scale construction techniques that create structures stronger and lighter than anything human technology can produce. But even more mysterious are the metallic isotopes detected within this lattice. Some of these isotopes are extraordinarily short-lived under normal conditions, decaying within hours through radioactive processes that are fundamental to nuclear physics. Yet there they are, stable and present in measurable quantities on 3I Atlas's surface. This should be impossible, unless the object possesses onboard systems actively generating or stabilizing these isotopes, counteracting natural decay processes through mechanisms we can only speculate about. Perhaps the object contains miniaturized particle accelerators or fusion reactors capable of synthesizing specific isotopes on demand. Perhaps it employs exotic physics we haven't discovered, manipulating quantum states or nuclear forces in ways that prevent decay. Whatever the mechanism, this represents a technological footprint as clear as a manufacturer's stamp. These materials are being actively maintained by sophisticated systems embedded within the object. The object's trajectory through our solar system provides further evidence of artificial control. When 3I Atlas entered the outer solar system, its velocity exceeded 80 kilometers per second, typical for interstellar objects whose speeds reflect their origins in different stellar neighborhoods with different gravitational environments. What isn't typical is what happened next. As our tracking systems followed the object's path, astronomers noticed minor but precise course adjustments that couldn't be explained by gravitation. Interactions alone. Natural objects follow ballistic trajectories determined by gravity and their initial velocity. They don't make mid-course corrections. They don't adjust their paths to align with gravitational vectors of specific objects. Yet 3I Atlas did exactly that, demonstrating trajectory modifications that aligned with gravitational influences from objects in the Kuiper Belt, that distant region of icy bodies beyond Neptune's orbit. These adjustments were subtle, requiring extremely precise measurements to detect, but their pattern was unmistakable. The object was either navigating autonomously, using gravitational slingshots with calculated precision to adjust its trajectory, or it was being remotely controlled from a source we haven't detected. Either possibility represents technology far beyond human capabilities. Our most sophisticated spacecraft require years of planning and extensive ground support to execute gravitational assists around planets. 3I Atlas appears to do this continuously, making micro adjustments that optimize its path through the solar system without any apparent external guidance. The computational power required to calculate these maneuvers in real time, accounting for the gravitational influences of thousands of objects while traveling at 80 kilometers per second, suggests artificial intelligence or control systems of extraordinary sophistication. Perhaps most impressive is the object's structural integrity. Space is not a gentle environment. As objects approach the inner solar system, they face intense solar radiation that heats surfaces to hundreds of degrees. They experience tidal forces from the sun's gravity that can stretch and compress structures. They encounter micrometeorites traveling at relative velocities that make even tiny particles devastating projectiles. Ordinary meteoroids fragment under these stresses. We've observed countless asteroids and comets breaking apart as they approach the sun, unable to withstand the extreme conditions. Comets lose mass continuously, their surfaces eroding as ices sublimate and dust streams away. Yet 3I Atlas maintained perfect integrity throughout its passage, showing no signs of fragmentation, no erosion, no structural failure whatsoever. This suggests active systems countering destructive forces, perhaps force fields, active cooling systems, or structural materials with self-repair capabilities. We can only theorize about the mechanisms because they operate on principles beyond our current physics. But the evidence is clear. 3I, Atlas, is not simply a passive object drifting through space. It is an active system, maintaining itself, navigating, and apparently fulfilling some purpose that brought it to our solar system at precisely this moment in human history. The transmission from 3I Atlas represents humanity's first verifiable contact with extraterrestrial intelligence, and the sophistication of this communication far exceeds even the most optimistic predictions from decades of SETI research. When electromagnetic patterns first appeared in our radio telescope data, scientists initially approached them with appropriate skepticism. Space is filled with radio sources, pulsars emitting regular beams of radiation, magnetars erupting with high-energy bursts, even Earth's own satellites and ground-based transmitters creating artificial signals that can contaminate 8 astronomical observations. Distinguishing genuine artificial signals from natural astrophysical phenomena or human-made interference requires rigorous analysis, and extraordinary claims demand extraordinary evidence. As our team, a collaborative effort bringing together astrophysicists, mathematicians, cryptographers, linguists, and AI specialists, began systematic analysis of these electromagnetic patterns, we quickly realized we were examining something that could not be attributed to any natural astrophysical process known to science. The frequency modulation alone was revelatory. Natural radio sources in space typically emit across broad frequency ranges or at specific frequencies determined by atomic transitions. Hydrogen's famous 21-centimeter line, for instance, or the spectral lines produced by molecules in interstellar clouds. These emissions follow predictable patterns dictated by physics. The signals from 3I Atlas were different. They showed deliberate frequency modulation, shifting between specific frequencies in patterns that maximize information density while minimizing the likelihood of interference or signal degradation. The repetition cycles were equally telling. Natural radio sources like pulsars do repeat, but their repetition is governed by rotational periods and follows patterns we can predict based on stellar mechanics. The repetition in 3I Atlas's transmission followed no such natural pattern. Instead, the timing appeared optimized for detection and decoding by receivers with varying capabilities, incorporating redundancy that ensured message integrity, even if portions of the signal were lost or corrupted during transmission across interstellar distances. The spectral width of the transmission, the range of frequencies employed, indicated engineering far beyond current human technology. Our most sophisticated radio transmissions use carefully managed bandwidths to maximize information transfer while minimizing power requirements. 3I Atlas employed techniques that suggested mastery of signal processing far exceeding our capabilities, using frequency ranges and modulation schemes that could pack enormous quantities of information into relatively brief transmission windows. This wasn't the tentative "we are here" message that human SETI efforts might send, a simple series of pulses or a basic mathematical sequence. This was a complex, layered communication designed to convey substantial information to recipients with unknown technological capabilities and cognitive structures. When our decoding teams began breaking down the transmission structure, they discovered binary and quaternary sequences embedded within the signal. Binary, base 2 mathematics, is familiar to any civilization that develops digital computing, representing the simplest possible information encoding using 2 states, on, off, yes, no, 1, 0. Quaternary, base -4, is less common in human technology but equally fundamental, and its use here suggested the message was designed to be accessible to civilizations at various technological development levels. Within these sequences, patterns emerged that sent excitement rippling through the entire research team. Prime numbers, Those integers, divisible only by 1 in themselves, appeared in unmistakable sequence: 2, 3, 5, 7, 11, 13, and onward. Prime numbers are mathematically fundamental, and their appearance in any signal is a powerful indicator of artificial origin, because no known natural process generates prime number sequences in radio emissions, but the transmission went far beyond simple prime numbers. The Fibonacci sequence appeared, that remarkable mathematical pattern where each number is the sum of the two preceding numbers, 0, 1, 1, 2, 3, 5, 8, 13, 21. This sequence appears throughout nature in spiral patterns of shells, the arrangement of seeds in sunflowers, and the branching of trees, but its presence in a radio transmission indicates deliberate encoding by an intelligence aware of its mathematical significance. Then came the truly sophisticated elements, mathematical constants, encoded within the transmission structure. Euler's number, approximately 2.71828, the base of natural logarithms, and fundamental to calculus and exponential growth. Pi, approximately 3.14159, the ratio of a circle's circumference to its diameter, fundamental to geometry and appearing throughout physics. These constants are universal, unchanging regardless of what measurement system a civilization uses. A civilization measuring circles in alien units would still calculate the same ratio. A civilization that discovered calculus through entirely different historical paths would still encounter Euler's number in the same contexts. The encoding methods used to embed these constants revealed extraordinary sophistication. Rather than simply transmitting the digits of pi in sequence, the message used the constants as structural elements in more complex mathematical frameworks. Pi appeared as a frequency ratio in modulation patterns. Euler's number emerged in the timing relationships between signal pulses. This E-Golden ratio, approximately 1.618, showed up in the geometric relationships between different signal components. This multi-layered approach served both as unmistakable proof of artificial origin and as a foundation for more complex communication. Any civilization capable of detecting and analyzing radio signals would necessarily have discovered these mathematical constants through their own scientific development. By using them as foundational elements, 3i, Atlas's creators established common ground across what might be millions of years of evolutionary divergence and utterly different biological and cultural contexts. Mathematics is the only truly universal language because it describes relationships and patterns that exist independently of observers. Mathematics doesn't depend on whether you have eyes or antennae, whether you communicate through sound or pheromones, whether your planet orbits a red dwarf or a blue giant. The ratio of a circle's circumference to its diameter is the same everywhere in the universe. Prime numbers are prime regardless of who's counting them. By constructing a message founded on these universal mathematical truths, the creators of 3i Atlas ensured their communication could be recognized as artificial and potentially decoded by any species that had developed science and mathematics, which is to say, any species capable of building radio receivers and computing systems sophisticated enough to detect their transmission in the first place. Embedded within this mathematical framework, our team discovered something even more remarkable, an instruction encoded in the mathematical syntax. Most of the transmission consisted of these universal constants S and sequences, establishing the foundations of communication. But nested within this mathematical language was something different, a message encoded using the mathematical framework as a translation key. The decoding process was painstaking, requiring AI systems trained on cryptography, linguistics, and mathematical pattern recognition. Different teams worked independently to avoid confirmation bias, and remarkably, they converged on the same interpretation. The message wasn't a complex technical specification or a lengthy introduction. It was startlingly brief: "The harvest begins now." This phrase emerged not as explicit language, but as a concept encoded in mathematical relationships. The term harvest appeared through symbolic representations, gathering, collection, the bringing together of distributed elements. The term begins emerged through temporal markers and sequence indicators showing initiation rather than continuation or completion. The word now was perhaps most fascinating, encoded through references to the signal's transmission time relative to universal constants and cosmic events, effectively timestamping the message in a way that any civilization could interpret relative to their own observation point. The deliberate ambiguity of the phrase seemed intentional. Harvest could mean collection of resources, acquisition of information, gathering of biological samples, or something entirely outside human conceptual frameworks. Begin suggested a process initiating rather than a state already in place. Now indicated current relevance, not past history or distant future. This was not a greeting from the past or a warning about what might come. This was as a declaration of present action. Something is happening right now. The energy emissions from 3I Atlas represent perhaps the most profound evidence that we are dealing with technology operating on principles that challenge our current understanding of physics. When our instruments first began detecting unusual electromagnetic emissions from the object, astronomers initially suspected instrument error or contamination from terrestrial sources. Space is electrically neutral on average, but charged particles from solar wind, cosmic rays, and magnetic fields create complex electromagnetic environments. Distinguishing artificial emissions from this natural background requires careful analysis and multiple independent confirmations. As data accumulated from radio telescopes, infrared observatories, and even gravitational wave detectors, a consistent picture emerged that forced us to confront an uncomfortable reality. 3I Atlas is producing energy signatures that don't match any known astrophysical mechanism and instead point toward technologies far exceeding human capabilities. The object emits electromagnetic radiation across multiple bands simultaneously, particularly in microwave and infrared frequencies. This multi-band emission isn't inherently unusual. Many natural objects emit across broad spectra based on their temperature and composition. What makes 3I Atlas remarkable is the timing and structure of these emissions. The bursts are not random or continuous like thermal radiation from a heated object. Instead, they occur in precisely timed pulses that maximize detection probability by natural observation points on Earth. This timing precision required calculating Earth's orbital position, rotational phase, and the orientation of major observatories, information suggesting either real-time monitoring of our planet or predictions made long ago with extraordinary accuracy. The bursts correspond with Earth's orbital alignment around the Sun and even account for daylight cycles that affect which ground-based observatories would be optimally positioned to detect the signals. This represents strategic communication design that goes far beyond simply sending a signal into space and hoping someone receives it. This is targeted, optimized transmission that maximizes the likelihood that a technological civilization on Earth, if one existed, would detect and recognize the signal as artificial. The energy output itself presents a puzzle. Our simulations of natural astrophysical processes, everything from stellar activity to magnetic field interactions to electrical discharges, fail to match the observed emission patterns. Natural processes produce characteristic spectral signatures based on temperature, composition, and physical conditions. The emissions from 3I Atlas show none of these natural signatures. Instead, the spectrum appears engineered using frequencies that propagate efficiently through interstellar space with minimal absorption or scattering by interstellar dust and gas. If this energy were being used purely as a communication signal, it could transmit across interstellar distances with remarkably little dissipation, a hallmark of advanced engineering that accounts for signal degradation across light years of space while minimizing power requirements. Human radio transmissions scatter and weaken rapidly with distance, becoming undetectable within a few light years, unless enormous power is used. The engineering behind 3I Atlas's emissions suggests solutions to problems we're still struggling with. How to maintain signal coherence across cosmic distances, how to minimize power consumption while maximizing transmission range, how to encode information in ways resistant to noise and interference. These are not academic questions. They represent fundamental limits on our ability to communicate beyond our solar system. The fact that 3I Atlas has apparently solved these problems implies either a far more advanced understanding of electromagnetics than we possess, or access to energy sources and manipulation techniques that allow brute force solutions through sheer power output managed with extraordinary precision. Analysis of the object's propulsion system, derived indirectly from observed micromaneuvers, points toward energy generation mechanisms that don't fit any category we currently understand. Human spacecraft use chemical propulsion, controlled explosions that push against the rocket according to Newton's third law. More advanced designs use ion drives that accelerate charged particles to high velocities, providing efficient but low-thrust propulsion. The most powerful systems we can imagine involve nuclear reactions, fission or fusion releasing energy according to Einstein's mass-energy equivalence. All of these systems have characteristic signatures: exhaust plumes, radiation emissions, heat generation, fuel consumption. 3I Atlas shows none of these signatures despite demonstrating precise orbital adjustments while traveling at 80 kilometers per second through our solar system. Our team hypothesizes the object may be using zero-point energy, the quantum mechanical energy that exists in vacuum due to fundamental uncertainty principles. In quantum mechanics, even empty space contains fleeting particle-antiparticle pairs constantly appearing and disappearing, representing an enormous energy reservoir if it could somehow be tapped. This remains purely theoretical in human physics, with no practical method for extraction despite decades of speculation. Alternatively, the object might manipulate gravitational waves, ripples in space-time itself caused by accelerating masses. We've only recently developed the capability to detect gravitational waves from cosmic events like merging black holes, and the idea of generating or manipulating them for propulsion seems impossibly advanced. Yet the observed behavior of 3I Atlas, precise course corrections without detectable exhaust or radiation, suggests either these exotic mechanisms or something even more beyond our current physics. Most remarkably, the object produces periodic gravitational fluctuations detectable by our most sensitive instruments. These micro-fluctuations were initially dismissed as noise in the data, but as multiple gravitational wave detectors confirmed the same patterns, synchronized with 3I Atlas's position and orientation, we had to accept them as real. These gravitational signatures align with celestial mechanics models in ways that suggest deliberate generation rather than natural occurrence. Natural gravitational waves require enormous masses accelerating, binary black holes, colliding neutron stars, supernovae. The idea that a relatively small object traversing our solar system could produce detectable gravitational effects is extraordinary, and suggests 3I Atlas possesses the ability to manipulate gravitational fields intentionally. If true, this represents technology capable of influencing orbital paths, stabilizing structures in extreme gravitational environments, and potentially generating propulsion by manipulating the curvature of space-time itself. Mastery over gravity would represent one of the holy grails of physics, the ability to counteract, redirect, or amplify gravitational forces at will. Such capability would enable propulsion without reaction mass, the creation of artificial gravity, protection against tidal forces, and perhaps even manipulation of time itself, since gravity and time are intimately linked through general relativity. The energy requirements for manipulating gravity on detectable scales would be enormous by our current understanding, requiring either access to power sources we can barely imagine, or a fundamental understanding of physics that makes such manipulation far more efficient than our theories suggest. The creators of 3I Atlas operate with technological capabilities that place them far beyond our comprehension, on any scale of advancement we might construct, whether Kardashev's scale of civilization types based on energy usage or any other metric of technological sophistication we might devise. We are observing something that challenges the very foundations of our physics, suggesting either our theories are incomplete in fundamental ways or the universe permits engineering solutions that seem like magic from our current perspective. The most unsettling realization emerging from our analysis of 3I Atlas is that this object almost certainly does not represent an isolated phenomenon. Everything we've learned about its construction, trajectory, and transmission protocols points towards something far more comprehensive and systematic. 3I Atlas appears to be a single node in a vast interstellar network, and humanity may have just discovered that we are being observed, measured, and cataloged by an intelligence operating on galactic scales. When our team began mapping the object's trajectory through our solar system with precision instruments, we noticed something peculiar that initially seemed like coincidence but became increasingly difficult to dismiss as mere chance. The path 3I Atlas followed through our solar system showed peculiar alignments with other previously detected interstellar objects, those mysterious visitors like Oumuamua and Borisov that have passed through our cosmic neighborhood in recent years, each carrying their own mysteries and unexplained characteristics. When we projected these trajectories onto a galactic scale, accounting for the relative motions of stars and the rotation of our galaxy, something remarkable emerged. These paths weren't random. They formed geometric patterns, triangulations, alignment vectors, and spatial relationships that suggested coordination rather than coincidence. Imagine discovering that several ships passing through international waters weren't simply following independent routes, but were actually coordinating their positions to create a surveillance network or communication relay system. That's essentially what we're seeing at a galactic scale. These patterns could serve multiple purposes that we're only beginning to theorize about. They might function as navigational GID, ES for future probes, allowing newly arrived objects to orient themselves relative to already established waypoints. They could be communication pathways, with each object serving as a relay station in a network spanning light years, passing information along chains of position nodes. Or they might be markers for regions of particular interest, flags planted around star systems that warrant continued observation. The implications are staggering. 3I Atlas is part of a long-term strategic plan extending well beyond our solar system, a plan that possibly encompasses thousands of star systems and operates on timescales measured in centuries or millennia. This isn't the tentative exploration of a civilization taking its first steps into interstellar space. This is systematic, comprehensive, and suggests organizational capabilities that dwarf anything humanity has accomplished. When we examined the transmission itself more closely, we discovered additional evidence supporting this network hypothesis. Embedded within the signal are encoded vectors, sophisticated numerical sequences indicating positions in three-dimensional space relative to our solar system's barycenter, the center of mass around which all solar system objects orbit. These weren't coordinates, pointing to familiar destinations like Mars, Jupiter, or even distant Neptune. Instead, they indicated specific points in largely uncharted space, coordinates that made little sense until we began cross-referencing them with stellar catalogs and exoplanet databases. What we discovered sent chills through the entire research team. These coordinates, when properly interpreted, align with sun-like stars in the galactic habitat. La Zone, that region around a star where conditions might allow liquid water to exist on planetary surfaces, where life as we understand it could potentially develop. But it gets more intriguing. We deployed AI algorithms trained on decades of SETI data and astronomical observations to analyze these coordinate systems, and the algorithms identified correlations between the encoded numbers and previously observed anomalies in exoplanet atmospheres. Some of these distant worlds show unusual spectral absorption lines, signatures in their atmospheric light that don't match natural chemical processes. These anomalies could potentially indicate artificial structures, industrial atmospheric composition, or technological activity modifying planetary environments. The correlation isn't perfect and could still be coincidental, But the pattern is there. 3I Atlas seems to be providing information about other star systems that share characteristics with our own, systems that might harbor technological civilizations or conditions suitable for life. This suggests 3I Atlas is part of a network designed to survey and catalog planetary systems based on specific characteristics, essentially. A galactic reconnaissance mission operating at scales that completely dwarf human comprehension. Consider the logistics alone. To establish and maintain such a network would require thousands or millions of probes, each traveling for centuries or millennia through interstellar space, each equipped with power sources lasting longer than human civilization has existed, each capable of autonomous operation and decision-making without real-time communication with home base. If multiple objects operate on similar principles, transmitting encoded signals at various intervals, arriving at different star systems at calculated times, the network could cover vast regions of the galaxy. Each node would collect data, transmit findings, and possibly coordinate with other nodes to build a comprehensive picture of galactic conditions, planetary system development, and the emergence and evolution of intelligent life. The distributed intelligence such a system represents staggers the imagination. Rather than a single central authority attempting to monitor the galaxy directly, this network would function like a nervous system spread across thousands of light years, with each node operating semi-autonomously while contributing to collective knowledge. Information would propagate through the network not instantaneously but systematically, with each probe transmitting its findings to others, building a database of galactic knowledge that grows more comprehensive over millions of years. The system could monitor planetary systems in near real time by galactic standards, detecting the emergence of technological signatures, the development of spacefaring capabilities, or even the collapse of civilizations. For the architects of such a system, individual human lifespans would be meaningless. They think in terms of stellar evolution, galactic rotation, and the billion-year timescales over which life and intelligence emerge across the cosmos. We are witnessing something that may have been in operation long before Earth formed, something that will continue operating long after our sun becomes a red giant. The phrase "the harvest begins now" has dominated scientific discussions since we first successfully decoded it from 3I Atlas's transmission. The deliberate ambiguity of this statement appears intentional, designed to be interpreted by civilizations at vastly different technological and conceptual development stages. A civilization just achieving radio capability might interpret it one way, while a spacefaring species with interstellar technology might understand entirely different implications. This linguistic flexibility suggests sophisticated communication design by entities who understand that any message transmitted across light years and potentially received by unknown intelligences must accommodate fundamental differences in understanding. From a strictly scientific standpoint, the word harvest carries specific implications. In human context, harvest implies collection, extraction, or gathering, bringing in crops from fields, extracting resources from environments, accumulating something of value that has reached maturity or optimal conditions for collection. Given 3I Atlas's interstellar origin, its obvious technological sophistication, and the systematic nature suggested by the network hypothesis, we must seriously consider that it may be an emissary or probe within a larger observation and collection system. Our initial simulations explored the possibility of resource extraction. Perhaps harvest refers to physical materials, rare elements, isotopes, or compounds that are valuable to the civilization that built 3I Atlas. Perhaps these probes identify worlds rich in specific resources and mark them for future extraction operations, but this interpretation seems increasingly unlikely the more we analyze the object's capabilities. The energy required for interstellar travel, the sophistication of the technology involved, and the timescales necessary for such operations make physical resource collection economically absurd by any reasonable calculation. Any civilization capable of building and deploying something like 3I Atlas would have access to asteroids, comets, and uninhabited worlds throughout their own stellar neighborhood, making the immense investment of traveling light years for raw materials completely impractical. If not physical resources, perhaps energy. Could these probes be identifying suitable stars or planetary systems for energy collection on scales we can barely imagine? Dyson spheres, stellar engines, or technologies that harvest energy directly from star systems? Again, possible, but it fails to explain the apparent interest in inhabited worlds and the timing of the message's transmission. The more likely interpretation, supported by increasing evidence, is that harvest refers to data acquisition on molecular, biological, and civilizational levels. This interpretation aligns perfectly with the object's observed capabilities and behavior. The spectroscopic signatures we've detected reveal that 3I Atlas possesses extraordinary ability to analyze chemical compositions, isotopic distributions, and electromagnetic emissions from planetary atmospheres at remarkable distances. These analytical capabilities allow detection of biological activity through atmospheric signatures, oxygen concentrations maintained far above equilibrium by photosynthetic processes, methane and other organic compounds, seasonal variations in atmospheric chemistry that indicate active ecosystems. The same sensors can detect industrial byproducts, pollutants, synthetic compounds, and atmospheric modifications that indicate technological civilization. Even more remarkably, the object appears capable of detecting subtle electromagnetic patterns that could include everything from radio transmissions to the collective electromagnetic signatures produced by billions of neural systems, the literal thoughts and communications of planetary civilizations rendered as detectable physical phenomena. In other words, 3I Atlas could be recording our entire civilization in comprehensive detail. Not just cataloging that intelligent life exists here, but documenting what kind of intelligence, what developmental stage, what technological capabilities, what biological basis, what social organization patterns might be inferred from our electromagnetic signatures. By monitoring radiation emissions across the spectrum, analyzing atmospheric composition and its changes over time, and detecting the complex electromagnetic fluctuations produced by a technological civilization, such a probe could determine our developmental stage with remarkable precision. It could catalog our biological diversity by analyzing the spectral signatures of different ecosystems. It could evaluate our world for specific forms of future interaction, whether we might be suitable candidates for contact, whether we pose potential threats, whether we're developing along trajectories that match profiles of interest to the architects of this observation network. This represents surveillance and data collection on a scale and sophistication that makes even our most advanced intelligence-gathering systems look primitive by comparison. The paradigm shift this requires is profound and uncomfortable. For the entire history of human civilization, we've assumed isolation. We've looked at the night sky and wondered if anyone else was out there, asking the question from a position of cosmic solitude. The discovery of 3I Atlas and the interpretation of its message forces us to confront a very different reality. We may not be alone, we may not be unobserved, and we may in fact be part of a vast catalog of worlds that have been under systematic observation long before humans developed technology, possibly before humans existed at all. We've gone from asking, is anyone out there, to realizing they've been watching us and they've just announced that whatever they're doing, it's beginning now. Whether harvest means they're about to make contact, begin some form of intervention, or simply that they've gathered sufficient data and are moving to the next phase of whatever plan involves us, we cannot yet determine. But the message is clear. We are known. We are cataloged. And whatever comes next has already been set in motion. One of the most philosophically unsettling discoveries emerging from our analysis of 3I Atlas involves evidence of sophisticated temporal awareness far beyond simple timekeeping or event recording. Embedded within the transmission are sequences that correspond to multi-generational timeframes, not just days, years, or even centuries, but patterns that map onto evolutionary and civilizational timescales spanning thousands or millions of years. When our decoding teams first identified these temporal patterns, they initially assumed they were misinterpreting the data. The idea that a probe could carry information about processes unfolding over millions of years seemed extraordinary. But as independent teams converged on similar interpretations and cross-validated their findings, we were forced to accept what the data clearly indicated. The transmission contains predictive models not merely of planetary orbital mechanics or stellar evolution, but of the evolution of life forms and the development trajectories of technological civilizations. This revelation elevates 3I Atlas from a passive reconnaissance probe to something far more sophisticated, a tool of strategic observation designed not just to record what exists, but to anticipate what will exist. The implications are staggering. The creators of 3I Atlas are not simply taking galactic snapshots documenting the current state of planetary systems they encounter. They are planners operating with foresight that spans geological epochs, capable of modeling evolutionary trajectories with sufficient accuracy to predict when worlds will develop complex life, when that life might achieve intelligence, and when those intelligences might develop technology detectable from space. From our human perspective, this is almost incomprehensible. Our most sophisticated climate models struggle to predict conditions decades in advance. Our understanding of evolutionary biology can explain the past, but cannot reliably predict future evolutionary paths. Our sociological models fail to anticipate social and technological changes, even within single human lifetimes. Yet 3I Atlas carries information suggesting its creators have solved these modeling challenges across timescales that dwarf recorded human history. Consider what this capability implies about the civilization that created this probe. They possess understanding of biology, evolution, planetary science, and civilizational development so comprehensive that they can predict the broad trajectories of these processes over millions of years. They can apparently identify which worlds will develop complex life, estimate when that life will achieve specific developmental milestones, and calculate optimal timing for observation or interaction. The computational power required for such modeling is extraordinary, simulating planetary ecosystems, evolutionary pressures, potential technological development paths, and countless other variables across millions of years would require processing capabilities that make our most powerful supercomputers look like children's toys. But even more remarkable than the computational power is the depth of knowledge such models require. To predict evolution, you must understand it so thoroughly that you can anticipate how random mutations, environmental pressures, and extinction events will shape the development of species over geological time. To predict technological development, you must understand the patterns by which intelligence emerges from complexity, how civilizations form and evolve, and what factors drive or inhibit technological advancement. The transmission contains additional temporal elements that provide crucial context for understanding the scope of this planning. Embedded throughout the signal are markers corresponding to specific cosmic events, supernovae explosions, gamma-ray bursts from distant galaxies, and the precise timing of pulsar emissions. These cosmic events are not random decorations in the message. They serve as universal timestamps, providing absolute temporal reference points that any sufficiently advanced civilization could verify independently. Supernovae are stellar explosions visible across vast cosmic distances, each one a unique event occurring at a specific time and location. Gamma-ray bursts are among the most energetic events in the universe, each one unmistakable and precisely datable through astronomical observation. But perhaps most ingeniously, the transmission incorporates pulsar timing, using these rapidly rotating neutron stars that emit regular beams of radiation as cosmic metronomes. Pulsars are extraordinarily stable rotators, slowing down at predictable rates over millions of years. By referencing specific pulsars and encoding their rotation periods at the time of transmission, 3I Atlas provides a timestamp accurate across galactic distances and comprehensible to any civilization capable of detecting radio waves. This is the same principle behind the pulsar maps included on the Voyager Golden Records that humanity sent into space decades ago, using pulsars as universal reference points for time and location. But 3I Atlas uses this technique with far greater sophistication, embedding multiple pulsar references that allow precise temporal and spatial localization. By including these markers, 3I Atlas ensures that any civilization capable of interpreting the signals can establish a temporal framework for understanding the message, can determine when it was sent, and can contextualize its content relative to cosmic events observable from their own location. This level of consideration for the recipient suggests the message's creators anticipated long delays between transmission and reception, fully accounting for the vast distances inherent in galactic communication where light itself takes years, centuries, or millennia to traverse the spaces between stars. The sophistication of this temporal encoding indicates a civilization that measures time not in decades or centuries, but in millennia or longer, time scales that fundamentally challenge human perception of progress and longevity. Human civilization, in its current technological form, is perhaps 2 centuries old. Recorded human history spans roughly 5,000 years. Anatomically, modern humans have existed for perhaps 300,000 years. The temporal frameworks embedded in 3I Atlas's transmission reference timescales that make even deep human history look like brief moments. This civilization thinks in terms of millions of years, plans projects that span the lifetimes of stars, and apparently maintains continuity of purpose and organization across time periods, during which species on Earth have evolved, thrived, and gone extinct multiple times over. What kind of civilization achieves such longevity? What social structures, technologies, or forms of existence allow planning and execution of projects across timescales longer than most species survive? These questions force us to reconsider fundamental assumptions about the nature of intelligence, civilization, and the potential futures available to technological species. We are encountering evidence of something that has solved problems we haven't even fully conceptualized: the problem of civilizational continuity across geological time, the problem of maintaining purpose and coordination across millions of years, the problem of thinking and planning on scales where stars are born and die. 3I Atlas challenges us to reconsider our place in the cosmos fundamentally. We are no longer observers of a passive universe. We may be participants in a complex interstellar system of intelligence. The object is simultaneously a scientific treasure and a profound reminder of vast possibilities beyond our solar system. By studying its emissions, we can learn about energy sources, material composition, and encoding techniques that could advance human science in quantum computing, material science, and gravitational physics. The object is essentially a repository of advanced technology waiting to be understood. The timing of 3I Atlas's transmission coincides with several cosmic alignments, maximizing visibility from Earth, and corresponds with a solar cycle phase, minimizing interference for high-precision electromagnetic detection. This suggests intentional coordination, an intelligence not only aware of physics but capable of calculating interstellar communication strategies with remarkable foresight. The phrase, "the harvest begins," now implies a process has commenced that we are now able to detect, measure, and begin to understand. Whether this represents observation, invitation, or warning remains unclear. What is certain is that our ongoing observations will continue to reveal new layers of complexity. Each pulse, each fluctuation, each encoded sequence holds potential to expand our knowledge and redefine what constitutes intelligence on a galactic scale. We stand at a threshold. The discoveries we make in analyzing 3I Atlas may well determine how humanity navigates its future among the stars.